This article is titled Detect Changes in Terraform State. The first line straight away worries me. So, hello, I am having troubles with state file edit, not reflecting in plans. So straight away, state file edit. So he's obviously editing the file, or they, I should say they are editing the state file, which is an immediate no. That is an immediate don't do that straight away, straight off the bat. I'm worried already. Does anyone know whether I'm missing any steps? You are. You're missing the step where you don't edit the state file, so there's definitely that. I'm using Terraform Cloud. So let's look at the steps he's going through. He's downloading the state. He's doing edit state to reflect to wanted state with correct instance IDs and stuff. Terraform state push. Then he's checking that state in Terraform Cloud, and you can see that the state is being reflected up there in the cloud. Then he's doing a Terraform init, and then he's doing a Terraform plan. And then the plan still says forces replacements with IDs not to be found in the last state file. My question would be, where does it find this old ID? Okay, stop. The actual question should be, should I even be doing this? Editing the state file directly in Terraform is a really bad idea. There are little pieces of metadata inside the state file that sort of keep track of changes. There's a little counter at the top, for example, that increments every time there's a change. And there's other little pieces of information in there that Terraform uses to decide whether, what version of the state it's working with, and so on and so forth. So it's generally not a good idea to manipulate the state file directly. There have been times when I've had to do this in the past, but I'm talking like 3 years ago, maybe even 4 years ago now, when it was much more difficult to use the given commands to do these changes. But in this day and age, the commands that are available are actually pretty advanced. We don't really have to go in and manipulate the state file manually anymore. As you may or may not know, it's a JSON file, so it sort of almost invites you to come in and edit it, because JSON's this format that's allowed, that's sort of human readable and machine readable, but it's definitely not to be edited by a human being directly. You're meant to be using the subcommands. So the top comment on this one actually pretty much nails it right away. So we're going to get a different sort of perspective here. So Stocker rumbles, don't ever edit state files. Use state RM to remove things, or state MV to move them to a new resource. If you edit them, chances are you'll F it up. Very true indeed. So he's linked here very clearly to the manipulating state Terraform CLI, Terraform by HashiCorp documentation. He then goes on to clarify, but as someone who has edited them in the past, if I remember correctly, there's a count at the top that needs incrementing, but maybe I misremembered because I don't do it anymore. It's not safe. Absolutely correct. There is a counter at the top, but yeah, it's not safe. So let's check out this documentation. First of all, let's go back and actually look at the problem. It sounds to me like he's got a state file that is referenced in some instances. The instances have changed, and he wants to reflect the new instance IDs. Now, I don't have his state file or his setup in place, so I can't go through a line-by-line, command-by-command blow of what I would do. However, if we have a look at the documentation here, we can see that there are several state-related subcommands. So we can inspect the state, we can do forcing recreation, which is the take command and untake command. We can move things around, we can import pre-existing resources. We'll actually bring that up in another tab and we'll check that out. And then there's this disaster recovery related things as well. In this case, because he's created some instances in an existing state file, and he then wants to move the states to not look at the original instance IDs, but he now wants them to look at their new instance IDs, which can make sense if you've gone and manually created some instances for some reason on the side, and you're like, oh, I need my Terraform to now manage them. That might be something that you need to do, and that's clearly what needs to be done here. In that instance, you would use, in my opinion, the import. I would probably update the Terraform code to reflect the new instances and what they look like. And then I would import them. So I'd define the code and I'd import the new instances into the state. And then I'd state RM the existing ones, if they actually don't exist. If they exist in Terraform, I'd just delete the code, and then Terraform will take care of deleting them for you. And then provided you got your Terraform code to match the new ones that you've created, a Terraform plan should show that there are no changes because you've actually then imported those new bits of state. That would be how I would do it. I think that in some cases, infrastructure as code and these kind of tools, they do so much work for us. They make things so much better. They make things so much easier, so much safer, and so on and so forth. But they still have their limitations, and sometimes there is a little bit of manual work involved here. And in this case, this entire thing could have been avoided by, again, I don't know the background, but I would say by creating those secondary instances that he's now trying to import into the state. I would say that that could have been avoided by simply creating those new instances in the Terraform state to begin with. And then when you didn't need the old ones, you then just remove the code. And Terraform obviously sees that the code the state in the cloud provider no longer matches the desired state. And so it then deletes those instances for you. So that's where I would have gone with that. We can see here, if we have a look at the state, the overview of the state command. So this is literally how you would manipulate a Terraform state correctly. It requires zero editing of the Terraform state JSON file. First thing we can do is we can inspect the state. We can list all the resources that are in there. We can show specific information about a particular resource, and we can also refresh it. So if we have a look at list, it should give us an example. So we do a list. So we've done Terraform state list here, and then we can see that we've got an instance here called foo, and then this is an instance called bar with a count variable of 1. And so the internal name is obviously bar, and then the count variable is set to 1, so instance 0, and then instance 1. A count variable set to 2. And then we have an ELB. Which is inside of a module called ELB, which creates an AWS ELB for us called main. So we can see that with this simple command, we can get a list of the things that we're actually looking for, and we can even use filters here to ensure to look for specific things. So if we're interested in an instance called bar, then we can actually filter by that. And again, we can do that by module as well. If we go back, we can look at a show. If we go on down here, we can see that what we've got here is Terraform state show, Packer device worker. So that's obviously, that's not an AWS provider, that's the Packer provider, and it's a device called worker. And then you can see here that it actually gives you the HCL2 code here. It gives you the actual resource itself, including all of the attributes which you don't define. So remember, when you're creating stuff in AWS or in GCP or in Packer, you might not necessarily know certain attributes like the ID. You might have to then, Terraform has to go and speak to the API, and then it gets given back this API. This is called a computed attribute. And so in this case, this is how you would, if you needed this API, you would do your Terraform apply, and then you'd do your Terraform. You could either do your Terraform state show, and then you'd get back the resource with the ID field, or you could use an output, for example, in Terraform. So you could output this ID directly, and then when you do your Terraform apply and it finishes, that would appear at the bottom of the command line output. The ID would appear in there. So that's how you can view things within side of the state without having to actually open up that JSON file. My advice is just don't even open it. Don't even bother. Maybe just to peek in to a non-critical one to get an idea of, oh yeah, it's a JSON file. It's kind of what it looks like. You'll see that it's very complicated, and you should get a sense of almost dread when you look at it and go, yeah, I'm not touching that. That looks really complicated. It is really complicated. Tainting. So tainting is a really important one. So tainting is when, so I actually had a call today, about 10:30 today, about an hour ago. I had a call with someone who's currently reading through the book, the Learn DevOps book, and he was essentially having trouble SSHing into the instances that he'd created via Terraform. He'd created a key pair. He'd gone, obviously Terraform had used that key pair, and then he couldn't SSH in for some reason. So he tried to resolve the issue, and he found that he couldn't get that SSH key pair to work. What he was doing was he was updating the key pair in a Terraform, and then he was doing a Terraform apply, and then of course the key pair wasn't working. Now the problem there is there is no direct dependency between the key pair and the EC2 instance in that specific instance. So when he was then generating a new keeper, of course, the EC2 instance wasn't being recreated at all. So he was still using the prior keeper that he was having trouble with. So what I recommended he did in this case as a demonstration was he used the Terraform take command. So he tainted the two EC2 instances. He did a Terraform apply. Because they were marked as tainted in the state, Terraform then recreated those instances. It's really, really simple concept. Terraform taint, and then the resource. We can have a look at it here. It then, if we go down, Terraform taint, and then the address, so the internal address, if you like. So AWS instance foo, AWS instance dot bar, and then 1. So there's that count variable again. Obviously gives you an array and a list of instances. So that's referencing that, and you can go more and more complicated. And then once you do that, it marks as tainted. And when you do your Terraform apply, Terraform sees that as you saying, I want you to recreate that resource, regardless of what you want or what you think. I need you to recreate that resource for me. That's what the taint command does. Guess what the untaint command does? The untaint command untaints a resource. So you might find that you do a taint and then you do a Terraform plan. This is really powerful because you can do a taint and you can do a Terraform plan. And then you can actually see the entire structure of what's going to be recreated or destroyed or deleted or replaced, etc., based on that taint. And that allows you to go, whoa, hang on, I didn't realize that this other resource would be recreated as well, such as maybe a volume, maybe an EBS volume gets deleted. Shouldn't do, should just be detached and retached if it's a separate resource. However, it may get destroyed for some reason. Maybe the AWS API changes, and it's a side effect that you didn't predict. So then you can use a Terraform untaint it, and then you can come up with another plan to work out to get in place what it is that you're trying to do. So that's tainting. That's getting Terraform to forcefully delete things for you. I believe that what this individual needed to do was an import. We'll come to the import in a second. We'll continue here. So we've got moving here. So moving resources is, say, for example, you've called something AWS instance dot web server, and then you realize, oh, it's not a web server, it's a database server, and I've already created it, etc. I need to rename that now. You would use the move command. You would do Terraform state mv. You'd put your AWS instance.web server and you'd change it to AWS instance.database server. And that would allow you to rename it inside of the state, and then you can rename it inside of your code, and then there'll be no effect to that. So if you then do a Terraform plan, you will see no change because the state file matches the code, and so the actual state matches the desired state. So that's very useful if you need to rename things. The rm command will remove things from the state. So a good example there is you have so actually go back to that gentleman's problem. What he could have done was he could have an instance that's managed by the state and then an instance that is not managed by the state. Then what he could do is he could import this into his Terraform, and then let's say that this gets deleted manually for some reason, AWS console, AWS CLI tool, the state file's then disconnected. What you can then come in and do is do a Terraform state RM on that. So he could have imported, deleted that one, and then he could have came in and did a Terraform state RM to remove it from the state file. It's not necessarily the best way of doing it, but it's just sort of an example of where you would use this Terraform state RM. State replace provider command. I've actually never used that. That's oh, okay, yeah. So that kind of makes sense. So you're moving from an AWS provider to a similar provider, but you maybe a custom version of that provider. So that makes sense. So if you've used the official HashiCorp AWS provider, and now you've had to fork that project and create your own resources because maybe the official one isn't being kept up to date quick enough for your needs, you can use the replace provider to flip within the state provider, and then when it does a recalculation, obviously that then makes available all of your new code that you've implemented without impacting everything else. And so you don't have to then go in and change all the resources to use your new provider by changing the provider type. You can, the meta flag, you can just flip them over straight away. So it does it all in one go. That's quite nice. That's I can see that being very, very powerful. You've also got disaster recovery. So you got pull, push, and force unlock. Okay. So with state files that are remotely pushed, remotely managed, I should say, there may be a need for you to pull that down and maybe make a backup of it or push it remotely. The force unlock is in the event that you run Terraform and then it uses Terraform Cloud, or it uses GitLab's built-in Terraform state management, or perhaps you're using an S3 bucket in DynamoDB. It'll talk to DynamoDB, it'll create a lock for your state file, and then of course your Terraform then crashes partway through. The problem you have then is that that lock is still in place, so that if you then try and run your Terraform apply again, the state file will be locked. So the Terraform force on lock command will, as the sort of name implies, it will delete that lock so that you can then continue to manage that state file. And the state pull and state push allow you to pull and push state from a remote backend. So you may have a Terraform state file locally, you then you update it to use a remote. When you do a Terraform apply, it will actually say, hey, I'm going to push that remote up there for you. But you can also forcefully do a state push and a state pull as well. You might want to replace the current state you have with a different one. For example, maybe an existing state that you have is corrupt in some way or bad, but you have a backup, such as a backup in an S3 bucket that has versioning enabled. You can move that aside, and then you can do a pull, and then that will pull that down, and then Terraform will adjust and use that state file for you. So that's pretty good. This gentleman in our little problem up here definitely needed to use, in my opinion, the import command, which allows you to import existing resources. So it doesn't work with every resource. I do believe most resources do work, but it's sort of provider specific, and then it's resource specific within that provider as well. So, for example, AWS instances are absolutely 100% supported, but SageMaker clusters, or whatever they're called, may not be supported. You might not be able to import anything to do with SageMaker at this point in time. But what the import allows you to do is say, I've got existing Terraform code, we've got an old piece of infrastructure that we have to keep live that's not managed by Terraform, but we want to manage it by Terraform. What you would do is you use a Terraform import, you would give it the address, which is the internal Terraform address, AWS_instance.web server, for example, and then the ID, which is the ID in, again, for example, AWS. So you'd give it the instance ID, and then what it would do is it would go and fetch it, get all the information about it, it would bring that down, and put it inside the state at that address that you've specified it, and then that's now present in your state. What you have to be wary of here, though, is it doesn't generate a Terraform, it doesn't generate a HCL file for you, so it doesn't actually generate the Terraform code. Okay, so you have to then make sure that you're actually producing the actual code itself. Now, it can actually do that for you. As Julius has actually said here, the other usage is Terraform is state show to generate TF code. That's correct. If you do an import and then you use state show, it actually technically generates the code for you. So you can be a bit sneaky, and you can actually import, say, 5 resources. And then what you're actually able to then do is use the state show to generate the Terraform code for those resources. You can then output them into a file or individual files, and then you can then go in and you can either delete the computed attributes that you're not interested in, or you can just leave it as is. And then because the code will match the state, if you then attempt to do a Terraform apply, there will be no difference, because the resource exists in AWS, it exists in your code, and it exists inside of the state. Of course, if you then make a change to the code, Terraform then goes back to essentially its normal operation. And a good little tip there, thanks to Julio there in the chat, is if you use when you're generating the code, when you're using the state show, if you use the no color -no -color flag, that will mean that there are no color codes inside of the HCL code that gets produced. If you don't do that, when it attempts to push it out to a file, it will contain terminal color codes, which won't be pretty, and you'll have to sit there manually removing all of them. But if you use the -no -color flag, it won't include them for you, and it'll just give you raw text, plain text. So that's actually a really good tip. I believe that what this gentleman should have done was, instead of, he's got obviously separate instances over here that have got now new IDs. He could have done an import, in my opinion, generated the code, put that into his Terraform, and then done a plan. He would have seen that the Terraform state would have said, okay, I have this instance over here on the old ID. I've now got this new instance over here on the new ID. However, I've got that in my state. I'm aware of its existence. It looks perfectly fine to me. Good to go. And then I'd have just deleted the old instance, and he would have been in a perfect state. So that's my thoughts on this particular post here. To summarize, please don't edit your state file manually. It's an insane idea. And of course, use the provided tools if you need to. Use the provided Terraform state management tools, Terraform import, and so on and so forth in order to actually manipulate that file using Terraform official tools. Don't try and do it yourself. Very nice.